Hello everyone, in this video I'm going to show you how to find the shortest distance between a point and a vector line. Now a little bit of theory before we start. Whenever you have a line and a point, the first thing you need to know is that the shortest distance will always meet the line at 90 degrees. As they meet at 90 degrees, they are perpendicular. A little fact should go into your mind. We know that the dot product of the two movements along the line will equal 0. It is this fact that we are going to use to enable us to find the movement of vector B numerically, and then we can Pythag that to get the distance. So the best way to explain this is to go through an example. This is the one we're going to do. I have the equation of a line in Cartesian form, and we have a point A with the coordinates 1, 2, minus 1. Now, for these, I like to have the equation in the vector form, so the first thing I'm going to do is rewrite this equation as 1, 1, minus 3, plus lambda, 2, minus 2, minus 1. Now, I'm just going to draw the diagram again to make sure we know what's going on. This is our line for this equation. And we have a point here which has the coordinate of 1, 2, minus 1. Now remember, if it's a coordinate, I can write it as a vector because a coordinate is a positional vector, a movement from the origin to A. So I know we meet this line at 90 degrees. So our equation of the line, if we write it like this, so the x-coordinate is 1 plus 2 lambda. The y-coordinate 1 minus 2 lambda, middle row, and the bottom minus 3 minus lambda. That is the general form of any point on that line. So this is the equation of the line where lambda changes for every point you're on. This is a specific point on the line, and I'm going to call that point there, which I'm going to label B. Now I know the two movements across these lines are perpendicular, and to do the dot product A dot B equals 0, I need two movement vectors. I have one here. That's how I move along this line. But I also need the movement along this line as well to be able to dot product these two. So to get from B to A, you can do these lots of ways by subtracting and things like that. What I like to do is start here and think, how do I get from here to here? And what I can see there is that I need to add on 2 lambda. How do I get from here to here? Well, I need a 1 added on to get the 2, and I need to take away 2 lambda. And how do I get from minus 3 minus lambda to minus 1? Well, I need to increase by 2 and take away a lambda. So this one here is this movement along here. So we now have our two movement vectors. So what I will now do is dot product these two movements. Don't dot product using this term or even that one. These are all positions. We need movements, so I'll use this one and this one. So my dot product, so I'm going to label that B and A. So A dot B is 2 lambda, 1 minus 2 lambda, 2 minus lambda, dot producted with 2 minus 2 minus 1. I know this equals 0 because they meet in a perpendicular way. So let's now do the dot product. So that gives me 4 plus 9 lambda Lambda is minus 4/9. So let's go back and remind ourselves what we are doing. We were trying to find the shortest distance between this point here and the line. What we did, we wrote the general coordinate here, we've got the coordinate here, and we worked out the movement in between. We then dot producted the two to work out what lambda is. So if we want to actually find out this distance now, I need to know that movement as a number. So I'm going to use my distance here, b to a, and all I'm going to do is substitute minus 4/9 into that equation. And that gives me minus 8/9, minus 1/9, and minus 14/9. So that is how you move from point B to point A. So if I wanted to work out that distance, all I need to do is modulus that. So that means square each term, and because I'm squaring, I can ignore the fact I have a minus. And of course square root it, and that will give me square root of 29/3. So the shortest distance from point A to the line is root 29/3. Now, part B. Find the Cartesian line that is perpendicular to L that passes through A. So now I'm going to find the equation of this line. And if you remember, to find the equation of a line, we need a positional vector. We've got one of them. And I need a movement vector. I have one of those. Now, that is a bit of an awkward equation. I don't really want to write that a lot, but because I'm not actually finding a distance now, I just need a movement. As long as I have a multiple of this, I'll be fine. So the direction of this line, BA, would be, I'm going to times everything by minus 9. So I know the movement now is 8, 1, 14. These are parallel movements because this one is a multiple of this one. So this line here that goes through, so if this was L1, this would be L2. L2 would equal a position on that vector, 1, 2, minus 1, plus scalar dimension. So I've used lambda, I'm going to use mu this time, and then a movement along the line. This question just asked for it to be Cartesian, so now I'm just going to rewrite this as a Cartesian equation. And there we go. So this is quite a long method and worth quite a few marks in the exam. So lastly, just to remind yourself of the method, this is the method we used. You write your vector equation in a general form for a point on the line, which I call B. We find the movement vector from point B to point A. We then find the scalar product of A, the movement of B to A, and then the movement of vector L. We set that equal to 0 and solve. Now I'm just going to write there, this should be B to A, so I'm going to correct that. Then, once we've got lambda, we find actually what the equation B to A is as a number, and then we use Pythagoras on that to get us our equation. Thank you very much for listening.